Hello class, welcome to Statistics 3215, Module 1 Lecture 1. My name is Russ Frith and I'm your facilitator for this class. So let's get started with the lecture content. Anytime during the lecture content, if you have any questions, feel free to raise your hand or speak out your question and I can pause the lecture and address your question. So for this class, we have certain course activities. Each module will contain a reading assignment in your eText, learning widgets, a written discussion, multiple choice quizzes starting in Module 1, homework problems which will start in Module 2, a live classroom which will be a review of the week's topic. The final exam will be in week 6. In this class I require that you develop a course project. Each course project consists of a Word document that you will answer certain questions, and each course project will be done in a sequence of phases. So there will be 5 phases for your course project starting with this week. Let's get started with the content. Module 1 presents a review of a number of definitions that you will be using. Statistics is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. Notice that in this definition of statistics, it doesn't include complex computations of mathematical formulae. Okay? In this class, we'll be using a lot of numbers, but we will use what we will do is we will find the story that the numbers are telling using statistical methods. This is not a class in algebra or trigonometry or calculus. No, this is a class where we take accumulated data, which is often represented numerically, and try and find a story that it's telling. Data are the collection of observations such as measurements or survey responses that you want to study. A population is the complete collection of all measurements or data that are being considered. A sample is a subset of a population. Now, students often confuse population and sample. A population consists of everything, okay, whereas a sample is a subset of the population. In this class, we're going to be running statistics on samples of populations because oftentimes the populations are too large to make any computations practical. When we run statistics on samples, the statistics will give us a good indication of some property or conclusion that we can draw about the population. A parameter is a numerical measurement describing some characteristic of a population, such as mean, average, and so forth. A statistic is a numerical measurement describing some characteristic of a sample. Conducting a statistical study. Okay, so I believe you addressed a number of these points in your Module 1 discussion forum. So for instance, when you conduct a statistical study, you want to know what is the goal of this statistical study. What does the data mean? What is the source of the data? How was the data collected? What we'll be doing mostly in this class is analysis of data. Okay, we will be using graphs, Excel functions, and statistical software. Although we won't be using SAS or R. These are much more advanced statistical software packages. Once you do your analysis, you follow up your analysis with conclusions. When you generate a statistical result, you want to know if the result is meaningful. So I will show you how to determine if your statistical result is meaningful. You want to state the practical implications of the results, and then you want to state if the finding is useful or not, and if it can be leveraged to do something meaningful. So again, these 3 things were questions that you generally answered in your Module 1 discussion post. Types of data. There are at least 4 types of data in statistical analysis. Quantitative data consists of numeric counts or measurements. Categorical data consists of names or labels. Discrete data results when the number of possible values is either a finite number or a countable number. In general, discrete data are whole numbers bigger than 0. Continuous data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. You can think of the real number line as continuous data. For example, The length of time it takes students to complete their statistics exam is what type of data? Okay, it's continuous data because students can complete their exam at any time from the beginning, the time at which they start their exam. Types of data. There are 4 levels of measurement for data. Nominal data is data that is classified into categories that cannot be ordered or measured. So for example, male, female. You cannot order the 2 genders. Ordinal data is data that can be placed into categories that can be ordered or ranked. For instance, letter grades, A, B, C, D, F. Interval data is data that is ranked or arranged in order. The differences between the ordered data can be measured, but there is no true zero or starting point. For example, temperature. The difference between 72 degrees and 73 degrees is 1 degree. The difference between -1 degree and 1 degree is 2 degrees. Compare interval data with ratio data. Ratio data is ranked or arranged in order. The difference between the ordered data can be measured, but there is a true zero or starting point. Okay? For example, height, age, weight. The measurements cannot be below 0. You cannot have an age of less than 0. So ratio is kind of a subcategory of interval data. So when we analyze data, or when we collect data, there are different types of sampling. We can't, in general, sample the whole population. For instance, you can't go out and do a survey of every person in the United States. So you want to sample a subset of the population of the United States. So random sampling occurs if a sample is drawn in such a way that each time an item is selected, each item has an equal chance of being drawn. These are the kinds of samples that you will use in this class. When a sample is obtained by drawing every nth item on a list or production line, the sample is a systematic sample. You will have some word problems in later modules that deal with these kinds of samplings. A cluster sample is sometimes referred to as an area sample because it is frequently applied to a geographic basis. I noticed that a number of your posts in Module 1 dealt with cluster samples, especially for you folks who are majoring in criminal justice. You talked about analyzing crime in a particular census tract or census block. Stratified sampling involves dividing the population by characteristics called stratifying factors, such as gender, race, religion, or income. I believe in your project, there is an example, or one of the projects, or perhaps both of the projects, and we'll check at the end of this lecture, that the analysis you will be doing will be based on stratified sampling. For example, a survey was conducted to determine the preferred news source for homeowners in Illinois: television, internet, or newspaper. 10,000 households were divided by income level, and households from each income level were randomly selected to participate in the survey. What sampling technique is being used? Well, in this case, the 10,000 households were divided by income levels, so that makes this kind of sampling a stratified sample. It's not a cluster sample because there was no subdivision of the state of Illinois. The survey was conducted over the entire state. Now let's talk about frequency distribution tables. Suppose you want to measure the IQs of a sample of 78 children. So in the first column we have IQ score. 50 to 69, 70 to 89, and so forth. These are the ranges of IQs. In this particular sampling, 2 children were observed to have an IQ between 50 and 69. 33 children were observed to have an IQ between 70 and 89, and so forth. And notice that 1 child was observed to have an IQ between 130 and 149. So one of the things we like to know about frequency distribution tables is the relative frequency. So the relative frequency is the class frequency divided by the sum of all frequencies times 100%. So to calculate this 2.6% relative frequency, you take 2 and you divide it by the sum of all of the numbers in column 2, and you get 2.6%. To get to 35, we take this number 35 and we divide it by the sum of all the numbers in column 2. We'll be working more with relative frequency distributions in later modules. Here's another example. Finding the mean from a frequency distribution with the IQ score data. So to find the mean from a frequency distribution, you take the class midpoint. So what the class midpoint is it's the lowest value plus the highest value divided by 2. In other words, it's basically the average of the two endpoints of the range. So you calculate the class midpoint for all of these intervals and record them in the third column. Then you take the class midpoint and you multiply it by the frequency, and you get this f times x column right here, which is in the fourth column. Now you total the numbers. You total the frequencies, okay? Then you total the sum of the frequencies times the class midpoints, and you get these two numbers. Okay, so the mean from the frequency distribution is the total of the fourth column divided by the total of the second column. In this case, it's 92.3, which you can take to be the average IQ of the sampled children. Now let's talk about measures of center. Arithmetic mean. Arithmetic mean is the measure of center obtained by adding the values and dividing the total by the number of values. This is called average. The median is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. Mode is the value that occurs with the greatest frequency, and mid-range is the value midway between the maximum and minimum values in the original data set. Let's see some examples. How to calculate the mean. First of all, you need to understand what sigma notation means. Sigma represents the sum. So the sample mean is written as x bar. X bar is equal to the sum of the samples divided by the number of samples. So you add all the values and divide by the number of values. This is for the sample mean. For the population mean, we use the Greek letter mu. And mu is the sum of all of the data values in the population divided by the size of the population. You can use the Excel average function to calculate the mean. Median is different. To find the median of a data set, first arrange the values in order. Then, if the number of data values is odd, the median is the number located in the exact middle of the list. If the number of data values is even, the median is found by computing the mean of the two middle numbers. Excel has a median function. Mode. This is the number that appears most frequently. Consider part A. Consider the set of numbers. The number that occurs most frequently in the set of numbers is 1.10. Consider part B. The number that occurs most frequently in this set of numbers, well, there are two numbers. 27 occurs 3 times, and 55 occurs 3 times. So this is a bimodal set of numbers. In case C, there's no repetition of any of the numbers in the set, so this set has no mode. So let's do some examples. The weekly salaries in dollars of a sample of 10 medical assistants are listed below. What is the mean salary? Okay, so we can use Excel to do this. So what we can do is, in my Excel, I will go ahead and enter the data. So we have 805, 747, 546, 450, 1109, 975, 809, 767, 450, and 690. So assuming I entered all of this data correctly, let's calculate the average, or the mean of the numbers. So remember, in Excel, this is the average function. So we'll say equals average, okay, and then we need a range. And so you can select the range like so. What I did was I held my left mouse cursor down and I dragged the cursor to cover the entire range of the numbers. And then once I do that, I close the parentheses and hit enter. And so the average weekly salary in dollars is $734.80. So this is the average. What is the median salary of the registered nurses? Okay, so we can use the median, Excel median function. So this would be median. Okay, and then I will hold my left cursor down, drag, select the numbers in the range, close parentheses, and so the median is $757. If you have any questions, please feel free to speak out or raise your hand. So the mid-range of a set of numbers is the maximum value plus the minimum value divided by 2. Now let's talk about variation. So variation. A range is the difference between the max data value and the min data value. Okay, that's one indication of variation. A more specific or concise measure of variation is called the standard deviation. The standard deviation is a measure for a set of sample values. Note sample values, not population. It's denoted by the letter s, lowercase s, which shows how much the data values depart from the mean. If you represent the distribution of data values departing from the mean, and it stacks up like a very skinny bell-shaped curve like this, then you have a low standard deviation for your curve, for your data set, which means that the average value of your data set, or check that each data point in your data set doesn't depart too far from the average value. But if you have a flat-shaped bell-shaped curve like this, then you have a high standard deviation, and that means that the data points tend to depart more greatly than from the mean. The formula for the sample standard deviation is this. S is the standard deviation for your sample data set, and it's the square root of this ratio, where x bar is the average of your sample set, and x is a given value, given data point value. And the denominator, although it's kind of washed out in this illustration, the denominator is n minus 1. So properties of the sample standard deviation. Measure of all values from the mean, always positive, could be 0, but it's never negative. It can significantly increase in value with the inclusion of an outlier, which is a data value far away from other values. The units of standard deviation are the same as the data values. Population standard deviation is this. We use the letter sigma, the Greek letter sigma, to represent population standard deviation. I forgot to include a closed parenthetical mark here, so I can do this by editing it. I can include it right there. Okay, and so it's very similar in structure to the sample standard deviation, where mu is the population mean, x is a value of a population data point, and n is the number of elements in the population. All right, let's do an example. Find the standard deviation of 22, 22, 26, 24. Now, the average of the numbers is 23.5. I went ahead and pre-processed that. So that's my x bar in the formula. So what I do is I take the square root, and then I take each of the numbers and I plug it in to the sigma function. So the first term would be 22 minus 23.5, my first x. This 22 corresponds to x. I take that difference and I square it. And then I repeat the process. The next 22 is here, the 26 is here, and the 24 is here. So I take the sum of squares. I'm taking the numerator is the sum of squares. Each squared term is a data value minus the average. Okay, this is the numerator is the expansion of this sigma operator right here, and then I divide it by the number of samples, which is 4, minus 1, which is 3. So the standard deviation is the square root of 11/3, which is 1.9149. Of course, you can use Excel to find the sample standard deviation. Let's plug in our numbers: 22, 22, 26, and 24. And the Excel formula for standard deviation is equal to STD EVA. Okay, and then you select your range. And so, again, 1.9149 when rounded. All right, so now let's go back to our nursing salary distribution analysis. The weekly salaries, okay, again, here they are, and we want to know the standard deviation of the nurses' salaries. So let's go back to our Excel spreadsheet, and we can go equals STD EVA. Okay, and it's $247.28. that looks a bit different, doesn't it? Let's see, do I have the right data? It looks like the data are different. Okay, or I didn't, oh, I beg your pardon, I didn't select all of the data. Let me delete this. Sorry, my range was improper. Check that. Always check. Standard D. Okay, so starting with this number, I believe I had the wrong range. Okay. Okay, $213.23, so that's better. Okay, and so the closest answer they have here is $213.20. This 213.20 probably came about because they used the author computed the result manually as opposed to using Excel. So let's talk about variance. Variance is the square of the standard deviation. All right, and so here are the variable nomenclature that we'll use in this class. S is the sample standard deviation. S squared is the sample variance. Sigma is the population standard deviation, and sigma squared is the population variance. We'll talk more about variance in later modules. For data sets having a distribution that is approximately bell-shaped, which we'll call a normal distribution, the following properties apply. About 68% of all values fall within one standard deviation of the mean. Okay, think about what mean is and think about what one standard deviation is. About 95% of all values fall within two standard deviations of the mean. So, two standard deviations means that you take your data set, compute a standard deviation, and multiply that standard deviation by 2. Okay, and then 99.7% of all values fall within three standard deviations of the mean. Here's a graph that illustrates the distribution of data that is normally distributed. The mean, written here, I apologize, the illustration may be a bit small. Let me see if I can expand it. Give some better resolution here. So the mean is right here, written in the magenta X bar. Okay. Now, for this particular data set, it's normally distributed, and in a normally distributed data set, 68% of all data fall within X bar minus sigma, X bar plus sigma. That means that the values of the data set, 68% of the values will fall in this range. And then 95% of the values of the data set will fall within two standard deviations right here. Okay? And then 99.7% of the data will fall within three standard deviations. So let's look at these percentage signs right here. Well, this 34.13%, what does that mean? That means that, well, let's consider the curve itself, this blue curve. If we were to calculate, if we were to plot this blue curve on an XY coordinate axis, okay, and we let the y-axis be this magenta colored axis, and suppose you wanted to calculate the area under the curve from minus infinity to plus infinity. Well, for this curve, for a standard distribution curve, the area is one square unit. Okay? And what these percentages mean is that from x bar to x bar plus sigma, 34.13% of the area, okay, or in other words, 0.3413 square units lies in this this kind of trapezoidal region. Next, in this region between x bar plus sigma, x bar plus 2 sigma, 13.59% of the area lies in this trapezoidal region, or 0.1359%. Okay? Now, look here at x bar minus 3 sigma. If you were to calculate the area under the curve to the left of this value of x, 0.13% of the area under the curve is in this left tail region, or 0.013% of the area, or check that, 0.0013% of the area. So a very small amount of area. So let's do a problem. The length of time it takes students to complete an entrance exam for a university is normally distributed with a population mean of 120 minutes and a standard deviation of 30 minutes. So when we see the Greek letters, this is the population. What is the probability that one randomly selected student will take longer than 165 minutes to complete the entrance exam? All right, so now to do this kind of problem, we'll need a couple of things. All right, first of all, we need to understand, well, we need to parse the words, and the first key word in this problem is that the distribution is normally distributed. So you can start out by drawing a normal distribution curve. Just any arbitrary bell-shaped curve where the peak value is centered basically on the y. Okay, so do this. Okay. Now, what is the mean of the population? So mu is 120. So because it's normally distributed, the curve is symmetric about the mean, which is 120. Okay. And sigma, the standard deviation, is 30 minutes. Okay, so here is x plus sigma, just like in the illustration. Okay, now the problem with this information is that the data are not what are called standardized. In other words, there's no table or calculator that we can use to calculate this probability that one student will take 165 minutes to resolve the exam. But so in other words, we have to do what's called transform this data so that we can use a tool or a calculator or a table to solve this particular problem. Now, instead of transforming the data, a common term is to standardize the data. Okay, so the preferred term is standardize. Okay, standardize. So remember now, I'm just giving you a procedure. This procedure does not involve complex math. The first thing you want to do in a problem like this, that's structured like this, is standardize your data. Okay, so the standardization practice involves calculating a z-score. Okay, so the z-score is x minus mu over sigma. Okay, so we want to calculate this number, and in this particular case, x is 165 minutes. Okay, so 165 is clearly to the right of 120. So let's say 165 is here. Okay, so here's the 165. So we want to calculate the probability that one randomly selected student will take longer than 165 minutes. Okay, so longer than 165 means that it's this area. So you want to calculate the area of this shaded region to the right of 165. Okay, now, so to do that, we need to standardize this number and get a z-score for 165. So calculate the z-score. So x is 165, mu is 120, okay, and then you divide that by the standard deviation, which is 30. Okay, so that is what, 45 over 30. 165 minus 120 is 45, so that's 45 over 30, which is 1.5. All right, so that's your standardized score. Okay, so what do you do with this standardized score? Well, you may have recalled from an earlier statistics class that you look up the probability in your z-table, your standard normal cumulative probability table. So the z-scores are in the margins, the column in the margins. So we have a z-score of 1.5. Now remember, in the announcements, I posted this table. So you can download this table rather than having to sift through your ebook. So we look up 1.5. So 1.5 is here, and then you intersect this row right here, this row, with this column. Okay, and you concatenate the numbers. So you concatenate 1.5 with 0.00. And you get 1.50, and so the cumulative probability is 0.9332. Okay, so now what does 0.9332 tell us? Well, look here. Look at this illustration. Okay, the z is 1.5. Okay, so the gray area, notice this gray area, that is an area or a probability. You can use the terms interchangeably for this particular table. So this means that the gray area represents the area under the curve from minus infinity to 1.5, which is 0.9332. Okay, so let's write that down. Let's go back to our chart. So the z-score from the probability distribution table, okay, so so you would write this, the probability that z equals to 1.5 is equal to 0.9332. Okay, so remember what this tells us. These probabilities are the areas to the left of the z-score. So we can write here, you see this 165 here, standardized, that's 1.5. Okay, and recall, let's see here, can I change my pen color? Well, recall that these probabilities are the areas to the left. So that means this stippled area, this dotted area, this has an area of 0.9332, or 93% of the area. Okay, so we want the area of the hashed region. So to get the area of the hash region, recall that the area under the total curve is 1. So if we subtract off 0.9332, what do we get? Well, let's see. I'm not good at math either, so I'm going to use my calculator. I'm going to go 1 see if it'll work. Yeah, 1 minus 0.9332. And I get 0.0668. Okay. So I have 0.0668 as the probability that one randomly selected student will take longer than 165 minutes. Okay, or what is that? Or a 6% chance, 0.0668, or that is what, 6.7% chance. Okay, so let me check if that is in fact correct. One second. Yes, I believe that is the correct answer. Okay, so 6.7% chance that one student will take longer than 165 minutes. Okay. Let's see, I need a new page here. Let me see how to... All right, so let's go on to the second page. Okay, now what we can do is, I believe we can use we can calculate this in Excel. So let me show you how to use this in Excel. We use the normDist function in Excel. So let me pull up my Excel worksheet. Okay. Okay, so normDist is one way of calculating the area to the left of 165, and it goes like this. normDist, okay, and then you put in your x value, which is 165. That's your data point. Then the mean, which is 120. Even look at the IntelliSense of normDist. It even informs you of what the values are. And then the standard deviation is 30, and we want cumulative, okay? And so we get, again, 0.9331. So what we really want is we want 1 minus normDist, since we're looking at a value to the right of 165. And so that's 0.066807. Okay, good. All right, so let's look at the second problem example. The length of time that it takes students to complete the entrance exam for a university is normally distributed with a population mean of 120 minutes and a standard deviation of 30 minutes. What is the probability that the average of 25 randomly selected students will take between 115 and 125 minutes? Okay, so in this particular problem, unlike the previous problem, well, no, not unlike the previous problem, we now have a population sample of 25 students. Okay, and we have a complete population characterization. So you have to be very careful with this problem. We're dealing now with a sample, and so this causes our standard deviation value to change. Let me see, did I address this? Okay, so I have not addressed this yet. Okay, in another topic I will. Okay, when you have a problem like this, let me see, let me check. Did I not address this? I have not, okay. Okay, when you have a sample of a population, to calculate this, and you know, okay, I'll write this down. It's my eraser tool. When you know the population standard deviation and population size, okay, and you have a sample, you have a population sample, okay, then the standard deviation of the population, check that, the sample, the standard deviation of the sample okay, it is the population standard deviation divided by the square root of the size of the population. Okay, so that's S. Okay, so now let's go back to our problem. The length of time it takes students to complete the entrance exam is normally distributed, mean 120, standard deviation 30. What is the What is the probability that an average of 25 randomly selected students will take between 115 and 125 minutes? Okay, all right. So for this particular problem, N is the sample size. Okay, I may have misspoke earlier. N is the size of sample. Okay, so the way you would deal with this is the way the problem sets up is like this. So let me insert a blank page. Okay, so you have 25 students now. Okay, so the mean is 120. Okay, and you want to know what is the probability that the average of students between 115 and 125. So 115 is here. Okay, and 125 is here. Okay, and so for this sample, you want to find this area. Okay, so to find this area, what you'll do is you'll calculate the probability of 125, okay, which will give you to the area to the left, minus the probability of 115. Okay, so when you subtract off these two probabilities, you'll have this middle area. The only caveat to this problem is you have to use S. Okay, and so S is equal to sigma over the square root of n, which, okay, now our standard deviation is 30, and the sample size is 25. Okay, so that's equal to 30 over 5, so that's equal to 6. So that's the value we'll have to use for our standard deviation. So we can use norm dist again for this particular problem, or you can manually calculate it, okay, using the standardization techniques. Let's use norm dist. Okay, so I will go norm dist, okay, oops, I need the equal sign, don't I? Equals norm dist. Okay, so my x value is 125. My mean is 120. My standard deviation is 6. And we want cumulative minus norm dist, not norm dot dist. Make sure you use norm dist. Norm dist. In this case, it would be 115, 120, 6, and 1. Okay, so this is the probability that 25 randomly selected students will take between 115 and 125 minutes. And then so the probability is about 59.5%. So the shaded area, the shaded region is 59.53% of the area under the curve, or 0.5953 square units. Is that a choice? Yes, it would be choice A. Okay, so let's talk about another type of probability. Let's talk about the probability, the binomial, and I apologize, I have binomial, that should be binomial probability distribution. So a binomial probability distribution results from a procedure that meets all of the following requirements. The procedure has a fixed number of trials. The trials are independent, such as in a coin toss. Each trial must have all outcomes classified into two categories, success or failure, or heads or tails. The probability of a success remains the same in all trials. Okay? So uppercase S and uppercase F denote success and failure respectively. So the two possible categories of outcomes. P and Q will denote the probabilities of success and failure respectively. So the probability of success is P. The probability of failure is 1 minus P, which is equal to Q. Notice that the sum of the probabilities must equal to 100%. So with binomial probability distributions, we have a number of variables. N denotes the fixed number of trials, such as a number of coin tosses. X denotes a specific number of successes in N trials. Okay? So note that X has to be between 0 and N. Q denotes the probability of failure in one of the N trials. Q is also equal to 1 minus P. And P of X denotes the probability of getting exactly X successes among N trials. So we have this formula. So here's the formula for the binomial probability distribution. P of X is equal to N factorial divided by N minus X factorial times X factorial times the probability of success raised to the value of X, okay, times the probability of failure raised to the power of N minus X. And here are the variable definitions. So let's do an example, an application. Okay. 7 customers enter a clothing store and are observed to determine if they will make a purchase. The store owner states that there's a 75% chance of a customer making a purchase. The random variable X represents the number of customers making a purchase. What is the probability that exactly 4 customers make a purchase? Okay, so let's see how we solve this. Well, so when a customer comes into the store, the customer will either make a purchase or leave the store without making a purchase. So this is an example of a binomial probability distribution. In this case, the number of trials is 7. Okay? The number of successes will be the number of customers making a purchase. The number of failures. Okay, so check that. The probability of success is 75%. So P is equal to 0.75. The probability of not making a purchase is Q, which is 1 minus P, which is 0.25. Okay, so we can wire these numbers in to the binomial distribution formula. So we want the probability of 4 purchases, okay, and so that would equal to N factorial divided by, okay, so N minus X is 3, okay, and then right here, X factorial is 4 factorial, okay, and then we want to multiply that by 0.75, that's our P value. I'm looking at this quantity right here, X 75 to the 4th, and then Q, which is 0.25, to the N minus X power, which is 3. So we need a calculator to solve this. Well, okay, so now 7 factorial, of course, is 7 times 6 times 5 times 4 factorial over 3 factorial, 4 factorial. Okay, so these 4 factorials cancel. Okay, so 7 times 3, 6 is 3 times 2, right? And 3 factorial is 3 times 2, so that cancels. So we're left with 35. Okay, so this number right here is 35. So the rest we'll need a calculator for. Okay, so let's pull up the calculator. I have 2 calculators open for some reason. All right, so second on, clear, second off, try again. Okay, so we have 35 times, okay, so we need 0.75 raised to the 4th power. So that would be 0.75. Let's see, let's do it. I think I can do this. Raised to the 4th power times 0.25 raised to the 3rd power. Okay, so I have a 17.3% chance that 4 customers out of 7 will make a purchase. If you have any questions, feel free to ask. Okay. So we can calculate the probabilities where the data are distributed in a binomial fashion. So what other things can we do with the binomial distribution? Well, the mean of a binomial distribution is the number of elements times the probability of success. The variance, okay, which is the standard deviation squared, is the product of the number of elements times the probability of success times the probability of failure. Okay, so let's consider this problem. Seven customers enter a clothing store and are observed to determine if they will make a purchase. The store owner states that there is a 75% chance of a customer making a purchase. The random variable x represents a customer making a purchase. So we want to calculate the mean, variance, and standard deviation of the customers making a purchase. All right, so we'll use these formulae to calculate these quantities. So let me go insert, blank page. All right, so the first thing is we want the mean. So the mean of the population, which is 7. Okay, so n is 7, right? Is that how many? Let me check. Yeah, 7. And then the probability of success is 3/4. So the mean is 21 over 4, which is 5.25. Okay. And what else? Variance, right? So the variance is sigma squared, which is n times p times q. Okay. Well, n times p is just 21 over 4.
And Q is what, 1/4, right? So that's 21/16. So that's 1 and 5/16. Okay, and then what else? Standard deviation. Okay, so the standard deviation is just the square root of 21 over 4, right? I just took the square root of, just took the square root of this NPQ product, and you'll have that result. Okay, let's look at another example. Burger King has a 95% recognition rate. 12 individuals are randomly selected to participate in a study of the individuals that recognize the Burger King logo. For such a group, find the mean and standard deviation. Okay, so the mean would be the sample size, okay, times p. So in this case, check that. N is the population size, which is 12, and p is the probability of success is 95. So the mean is 11.4. The standard deviation is the square root of NPQ. Okay, now Q is just 1 minus P, which is 0.05. And so after doing the calculation, you get 0.8 as the standard deviation. So how do we use this information? We use what's called the range rule of thumb to find the minimum and maximum usual number of people who would recognize the Burger King logo. So the range rule of thumb is the mean plus 2 times the standard deviation. As the right endpoint, the left endpoint is the mean minus 2 times the standard deviation. And so when you calculate this, the mean, which is 11.4, plus 2 times the standard deviation, which is 1.6, you add the two together and you round because you can't have fractions of people. And so you would have 13 people on the right endpoint and I guess 9.8 people or 10 people on the left endpoint. So if a particular group of 12 people had all 12 recognized the Burger King logo, that would not be unusual because 12 falls within the range of 10 to 13. Okay, so this is the range of when you select 12 people at random in society. This would be the range for which you would find the number of people in that interval who would recognize the Burger King logo. Okay, so between 10 and 13 people. Okay, all right. So let's talk about the central limit theorem. The central limit theorem. The random variable x has a distribution which may or may not be normal with mean mu and standard deviation sigma. A simple random samples all of size n are selected from the population. The samples are selected so that all possible samples of the same size n have the same chance of being selected. So this is a key point. You have a population, okay, and then you go about selecting samples, 1 sample, 2 sample, 3 samples from the population. But each sample that you select has n elements, okay? Now, each element in a given sample has the same chance of being selected. So if you have sample 1, element 5, well, that has the same chance of being selected as sample 5, element 3, okay? So everybody has, it's a random sampling, okay? There's nothing contrived or mechanical about the sampling process. It's a completely random process. The distribution of a sample will, as the sample size increases, approach a normal distribution. Okay, so that's one of the things you should strive for when you sample your population, and that's one thing I tried to ask a number of you in your discussion posts. What kind of sample do you have? And so you want a sample large enough that comes close to having a normal or near normal distribution. The mean of the sample means is the population mean. Okay. For a large enough sample. And as we've seen earlier, the standard deviation of all sample means is sigma divided by the square root of the sample size. For samples of size n larger than 30, the distribution of the sample means can be approximately reasonably well by a normal distribution. So if your sample size is 30 for a particular population, then you can pretty much use the normal distribution considerations. The approximation becomes closer to a normal distribution, of course, as the sample size n becomes larger. If the original population is normally distributed, then for any sample size n, the sample means will be normally distributed, not just for values of n larger than 30. So if you're given information that the population is normally distributed, then the means will be normally distributed as well for the samples. Okay, so we have the mean of the sample means, okay, is equal to the population mean, and then the standard deviation of the sample mean, okay, is equal to the population standard deviation divided by the square root of the sample size. We'll be working with this in later modules. Okay, so we're almost done with today's lecture. Let's talk about the course project. Okay, so in the course project, you're provided with two options. Okay, option one allows you to analyze job salaries for the state of Minnesota. Okay, so you're given the scenario and you're given a data set. Option two allows you to analyze the ages of infectious disease patients at the NCLEX Memorial Hospital. You're given a problem description and an accompanying data set as well. So for your first phase report, okay, describe the scenario and data set. Provide a brief overview of the scenario you're given and the data set that you'll be analyzing. Now, in your data set, classify the variables as quantitative or qualitative, discrete or continuous, and describe the level of measurement for each of the variables included in your data set. Okay, so we've earlier at the beginning of this module, I gave you definitions for all these terms. So you should be able to respond to this first stanza of your phase one report using the definitions I provided at the beginning of this module. Discuss the importance of the measures of center and the measures of variation. What are the measures of center and why are they important? Okay, so we did talk about the measures of center earlier. Those would basically include your mean, mean, median, mode, standard deviation, and so forth. So what are the measures of variation? Okay, measures of variation is your standard deviation. And why is it important? Okay, so why is standard deviation important? Okay, so calculate the measures of center and measures of variation and interpret your results. So here you go. You want to calculate the mean, median, mode, mid-range, range, variance, and standard deviation. Recap your ideas by summarizing your information presented. Okay, now one thing that I require in your reports here, make sure you note these two items. Be sure to use the equation editor for all equations and submit your report as a Microsoft Word document. Now I realize that a number of you probably aren't familiar with the Microsoft Word equation editor. You need to become familiar with that. Okay, so I can give you a brief example. Let's go back to one of these formulae and I'll give you a brief intro into how to use the equation editor. Suppose you want this formula, the binomial distribution formula, as a formula in your report. So how would you edit that? Okay, how would you include that in the report? Okay, to do that, what you need to do is you need to go to, now this is a Word document, you go to the insert mode, okay, and then right here you have equation. So you click on the equation, okay, and notice that this gray, when you click on it, this gray edit template pops up. So you just click inside of it, okay, and you just start typing inside of it. So I put my cursor inside of the gray area and I type p of x. Okay, that was simple enough. Now notice that the coefficient is a fraction. So how do you edit a fraction in the equation editor? Well, look, right here, you have fraction. Okay, so go ahead, click on the fraction template, and then you want something that looks like this. So go ahead and type your fraction and you'll have two squares. So you want to edit the numerator. So again, I clicked on the top square and it went to gray mode. And basically I'm in edit mode in that. So I want to type n and then factorial. So I type n exclamation point. All right, now I go to the denominator, highlight that, okay, and so I type n minus x, okay, factorial, okay, and then I want x factorial. So now I have my coefficient. Now, the coefficient of the p to the x term. So what I do is I take my right arrow cursor, my right arrow on my keyboard, and I hit it once, and notice that the cursor is positioned to the right of the coefficient. And so I want a multiplication symbol. So I type times, okay, and then I need p to the x, okay. So p to the x, this is an exponential term. So I select an exponential term. I go here, and I select this format, okay. So I select that. Now I put my cursor in the base of the exponent, okay, and I type p. Now I hit my right arrow key. It highlights the box, and then I type x, okay. So now that's the second term in the product. So now I hit my right arrow key again, which goes to the right of the p of x term, hit my multiplication symbol, okay, and then
again, I have another exponential term. So I go script, hit that, okay. Now I hit my left arrow to go back to the first square, the base of the exponent, type Q, right arrow to go to the exponent, and then I type n minus x. Okay, so that's a brief example of how to edit a formula in equation editor. Okay. All right, so what else do we have? That's the homework. Okay, so that's the report you'll be writing. The assignment should be formatted using APA guidelines and a minimum of 2 pages in length. Okay. All right, so now that we've walked through all of the technical content that you need for Module 1, we have Lesson 1 quiz questions. So there are 3 questions, each equally weighted. Okay, so the first question is, a coin is flipped 3 times. Denote X is the number of heads turn out in this experiment. What is the set of possible values of the variable X? So you toss a coin 3 times. What are the possible values? Okay. Okay. All right. And then suppose the coin is biased, okay, so that the probability that a head turns out in a flip is 0.6, okay. What is the mean and standard deviation of X? Okay, so remember, this is a coin toss, and coin tosses follow a binomial distribution, okay, but it's not a 50-50 head tail proposition. It's a 60-40 split, right? So you go back into the notes and look for the mean and standard deviation formulae for a binomial probability distribution. Okay, and what is the probability that the head turns out at least twice? Okay, so now to answer this question, this is kind of a trick question here. All right, so remember, the coin is flipped 3 times, okay? So the probability that it turns out at least twice is the probability of 2 plus the probability of 3, okay? Or you can take 1 minus the probability of 1. Okay, so give these problems some consideration, and we'll see where we go. Now, if you have any questions, feel free to post them in the student lounge, send me an email, and we can go from there. So as a reminder, the Phase 1 report is due this evening, Saturday evening at midnight, and you must complete your first quiz by midnight Sunday, which is, midnight Sunday. And so as a hint for the quiz, all of the technical content and representative problems that you'll need for the quiz are in this particular lecture. Okay, so that's all I have for now, and I look forward to to seeing your works.